question carefully. An object that weighs 8 pounds. So from this weight we can find the mass. So mass of the object is 8 pounds divided by 32, acceleration due to gravity, so 1/4. Stretches a spring 2 inches. That's the stretch length. Uppercase L is 2 inches. So need to convert into feet. So 1/6. From this stretch length, we can determine the spring constant. K is weight mg over stretch length. Weight is 8 divided by 1/6, which is 48. Okay. Now let's read the question more. The object is attached to a viscous fluid with a damping constant. Okay, so there is a damping. Gamma is 2. If the object is set in motion, okay, these are initial conditions, initial values. If the motion is set in motion from its equilibrium position. Equilibrium position means the initial displacement is nothing, 0. With a downward velocity. Downward means positive, upward means negative, right? So downward velocity. So u prime 0 is 2 inches. 2 means 2/12. 2/12, so 1/6. Find the position at any time t, that means u. Okay, the displacement u equals what? I mean, our function, pretty much what is u? Determine when the mass first returns to its equilibrium position. So the displacement will be just going back and forth, but when it starts from equilibrium, it moves downward because we have applied downward velocity. Then when it comes back to the equilibrium position, so we need to determine that time. Okay. Let's write down the model, and that we know that is mu double prime plus gamma u prime plus ku equals external forces, which is 0 in this case, no mention of that. M is 1/4 u double prime plus gamma is 2 u prime plus 48 u equals 0. Okay, let's multiply through by 4 to get rid of this fraction. So u double prime plus 8 u prime plus 192 u equals 0. Now let's solve this second order ODE. For we write down characteristic equation, which is r squared plus 8r plus 192 equals 0. Okay, let's solve this using quadratic formula. So r equals negative b plus minus square root of b squared minus 4 times 1 times 192, 768 for AC over 2a, 2 times 1, 2. Let's find this one. So do not cancel, or you can separate into two parts. Negative 8 plus minus 64 minus 768, that's 704, negative 704 over 2. Let's look at 704, okay, without negative. Does it have a perfect square factor? Divide by like 4, 9, 16, then go 25. 25 is not going to divide. 36, I'm just trying perfect square numbers. 64, yeah, 64 divides, that's the maximum. After 64 we are going to get 11, so no, nothing left. So 8, 11. So this one is negative 8 plus minus, the negative means I, square root of negative 1i, 8 root 11 over 2. Over 2 we can now separate into two parts, okay, and that is negative 4 plus minus 4 root 11i. Okay, this is like lambda plus minus mu I case. Now we can write down the solution based on these complex roots. Okay, so let me do that over here. Then the solution is C1 e raised to this number negative 4t cosine of 4 root 11t plus same thing for sine. C2 e raised to negative 4t sine 4 root 11t. Okay, now using these two initial conditions, we need to determine the values of C1 and C2. So let's use U0 equals 0. So using initial displacement is 0, so this is 0 when time is 0. So C1 times e raised to 0, which is 1, times cosine 0 times this number is 0, cosine 0 is 1, plus C2 e raised to 0 is 1, sine 0 is 0. So this is simply 0 and this is C1. So 0 equals C1. That means C1 is 0. Oh, that's good. Now we can simplify this solution. Okay, update U because C1 is 0, so we don't have to even work on this. So the displacement at any time t is given by now C2 e raised to negative 4t sine 4 root 11t. We have yet to determine the value of C2. We need to use second initial value, the initial velocity 1 over 6. Okay, so to apply that we need to find the derivative. Okay, then derivative of this function is, in fact, this is a product, so we must use the product rule. C2 we can just write down outside. Derivative of first factor, exponential function itself, times derivative of this, which is negative 4. So I'm going to write here. Derivative of first factor, leave second alone, plus leave first alone, derivative of second factor. Derivative of sine is cosine of this one times this number comes. So 4 root 11 cosine of 4 root 11t. Okay, so that's U prime. So using second initial condition, U prime 0, initial velocity was what, 1 over 6. So this is 1 over 6 equals C2 negative 4 times, we are plugging in t equals 0. So e raised to 0, 1 times sine of 0 is 0. In fact, the whole thing is 0, plus e raised to 0, because when t is 0, so 1 times 4 root 11 times cosine of 4 root 11t. T 0 means this is 0, cosine 0 is 1. Okay, so that is 1/6 equals, oh, this is 0, C2 4 root 11, or we can write 4 root 11 C2. Then we can isolate C2, divide by this, so 1 over, this goes on the bottom, 24 root 11. You don't have to rationalize. So here is the solution. Okay, that is the displacement at any time t with this C2. So thus ut equals 1 over 24 root 11 e raised to negative 4t, okay, sine 4 root 11t. Okay, and the question asks for more, by the way. If we read here, determine when the mass first returns to its equilibrium position. So this one, if we graph this function and we only look at in the right side because this is the positive time. So because of this negative, there will be a lot of movement in the left, but we don't care that part because we are looking for positive time. Then if you look at the graph, and it will be at 0 is 0, and at some point it will come back to 0, and that point graph, then you get time. That time will be your answer, which comes out to be 0.24, about that seconds. Okay, final.